Most people around the world speak one or two languages, but some can speak three or more. These people are called polyglots, and they are helping researchers better understand how the human brain deals with language. In a new study, a team of scientists monitored the brain activity of 34 polyglots. The polyglots spoke between 5 and 54 languages. The scientists used a method called functional magnetic resonance imaging, or fMRI. In fMRI, the brain is studied through images that measure changes in blood flow in different areas of the brain. The researchers used fMRI to study the brain as the polyglots listened to different languages. The researchers found that when the polyglots heard a language they knew, activity increased in the area of the brain involved with language processing. That area is the cerebral cortex. When they listened to a language they did not know or knew less well, there was less activity in the cerebral cortex. Evelina Fedorenko is a brain scientist at the Massachusetts Institute of Technology and a member of MIT's McGovern Institute for Brain Research. She was also a senior writer of the study, which recently appeared in the publication Cerebral Cortex. She explained the findings. We think this is because when you process a language that you know well, you can engage the full suite of linguistic operations, the operations that the language system in your brain supports, Fedorenko said. However, an exception caught the attention of the researchers. For many of the polyglot participants, listening to their native language produced less of a brain response compared to hearing other languages they knew. On average, the response was about 25% less. And in some of the polyglots, listening to their native language activated only one part of the brain's language network, not the whole thing. Olesya Jaroflov is a brain scientist at Carleton University in Canada. He also helped write the report. He said that the brain's neural processes were more efficient or effective when the polyglots heard their native language. Therefore, the language network in the brain does not activate as much as when they do native versus non-native language processing, Jaroflov said. The brain's language network involves a few areas in its frontal and temporal lobes. Saima Malik Moreleda is a doctoral student at the Harvard-MIT program in Speech and Hearing Bioscience and Technology. She was one of the lead writers of the study. She said, the findings suggest that the way the brain finds or extracts meaning in language governs the brain's response to language. The more meaning you can extract from the language input you are receiving, the greater the response in language regions, except for the native language, she said. Of the 34 polyglots who took part in the study, 20 were men and 14 were women. They were between 19 and 71 years old. 21 were native English speakers. The rest were native speakers of French, Russian, Spanish, Dutch, German, Hungarian, and Mandarin Chinese. Researchers monitored the polyglots' brain activity as they listened to recordings in 8 languages. 1 was their native language. 3 were languages they spoke well, somewhat well, or somewhat. The other 4 were languages they did not know. Half heard recordings of Lewis Carroll's Alice in Wonderland. The other half heard recordings of stories from the Christian religious book, the Bible. Fedorenko noted that a lot of work in language research has been centered on individuals with linguistic difficulties. But she said there is a lot that researchers can learn about the language process by studying so-called language experts, too.